Alright class, so what I want to do, I want to do a couple more titration problems to make sure that you get those down before we move on. So here's our first practice problem. Pause my video, do this, and then we're going to review it together. So in this problem, you have an ascorbic acid. Now what I want you to remember, every time you take a vitamin C pill, I want you to remember that vitamin C is ascorbic acid. So vitamin C is ascorbic acid. So what we have in this problem, we have ascorbic acid and we titrated it with sodium hydroxide. So what I have over here, I have sodium hydroxide. Always draw this down. Have a little scheme of what's going on. And my sodium hydroxide concentration is 0.467 molar. Okay? And you're going to do titration. And when you do titration, it says the end point. And what's the end point? The end point when it turns pink, right? That's our end point. The end point is after adding 14.5 ml of sodium hydroxide, then it's going to turn pink. So far, so good. Okay, and now what do I have down here? Down here, I have my ascorbic acid. Now, here's the thing. So you know that vitamin C is ascorbic acid. When you read this problem, we might say, I don't know what is the formula for ascorbic acid. And that's okay. You don't necessarily need to know the formula for ascorbic acid to be able to do this problem. There's one piece of information that I've given you that's enough to do this problem. I give you the molecular weight, and also I said this is a monoprotic acid. Go back. What was monoprotic acid? What does it mean to have a monoprotic acid? Mono means one. So, and product means proton, means H plus. So monoprotic acid has only one hydrogen. So what I'm going to put down here, I'm going to put down HA. Doesn't matter what the formula is. It's HA. It's an acid, it's going to start with H. And it's monoprotic acid, so it only has one H. We're good? And a lot of time, you're going to have an acid that you have no idea what the formula is. It's fine, as long as you know is it mono, diprotic acid, or tri. That's all you need to know. You can just put HA. Alright, so now the same as before. We've done this before. So here I have my sodium hydroxide. I want to keep adding, keep adding, keep adding. After I add 14.5, it's going to turn pink. Now I want to know how much of the acid I had in here. Now remember, molarity is moles per liter. That's the first thing you should always do. That molarity is moles per liter. And I'm going to figure out how many moles of the NaOH I added to this solution before it turned pink. Okay, I have the molarity and I know how much NaOH I added, so I can figure out the moles of NaOH that was added because I have the molarity and I know the volume, so I can figure out the moles of NaOH that was added. Okay, so the molarity of NaOH is 0.467 equals, I don't know the moles, but I know the volume. I added 14.5 milliliters. Molarity is moles per liter, so you have to have liter. So it will be 0.0145 liters. You follow me so far? Okay. So now what I do, my X, if I find out what X is, and let me see what I get for X. For X, I get 0.00677 moles of NaOH. Okay, so I figured out how many moles of NaOH I added, and then it turned pink. That's great, but what I'm looking for is acid. Now we said this is a monoprotic acid, so what this means is I added 0.00677 moles of NaOH, and then it turned pink. So how many moles of the acid did I have in here? Think about it. So I added 0.00677 moles of NaOH and then it turned pink. That means how many moles of the acid did I have here? The same amount. Because remember, you added base, it goes, reacts with the acid, neutralize it out. Base, acid, balance out. Base, acid, neutralize it out. And then finally you add a base and there is no more acid to neutralize it out, and that's when it turns pink. Because when you add the base, there is no more acid. You've already neutralize all the acid. Okay, so that means I had 0.00677 moles of ascorbic acid. Because after that, there was no more acid in there. That's the when I added, it turned pink. Are we good so far? Because each base is going to go and neutralize the acid. That's beautiful. Except I'm not done yet. So I figured out how many moles of the acid I had there. That's good. The question asks you, how many milligrams? I have moles. How do I go from moles to grams? Molecular weight. You know that really well. So 0.00677 moles of ascorbic acid, which I'm just writing at HA, doesn't matter. Okay, I want to convert it to gram using molecular weight. 1 mole of the acid is 176 grams. I give you the molecular weight in this problem so the moles can cancel out. What I end up with is grams, which is 1.19 grams of ascorbic acid. Now, the question doesn't ask you for grams, it asks you for milligrams, but molecular weight is moles per gram, so I can figure out grams, and then from here, I can easily convert it to milligrams. How do I do that? I don't want grams, I want milligrams on top. 1 gram is 1,000 milligrams, right? Because grams is a larger unit, 1 gram is 1,000 milligrams. What I end up getting is, I have to care about sig fig, I know, 1190 grams. Don't forget about sig fig, 1190 grams. Sounds good? Okay, so just remember, ascorbic acid is a monoprotic acid. It has 1 hydrogen. So if you don't know the formula, it's fine. You can just put HA and then do the problem. Okay, are you ready for the next one? Let's do the next one. Alright, good job so far. Now the next problem is a little bit more difficult, but if you can understand that, then we're in a really, really good shape. So, I'm going to put up the next problem. You ready? Okay, here is our next problem. 10.0 ml of phosphoric acid. Let's see if you remember the formula for phosphoric acid. 10.0 ml of phosphoric acid, which is H3PO4, is titrated with 0.501 molar NaOH. 14.2 ml of NaOH was added to reach the endpoint, okay? Again, what's an endpoint? That's when it's going to change color, right? That's when it's going to change color. What is the molarity of this acid? Endpoint will depend on what indicator you have. Phenolphthalein is a common one. It's going to turn pink. Okay, now you know already that what you're going to do, you are going to draw a picture. Please do that for me every time. And you're probably tired of me saying that, but it really helps. So we're going to draw a picture, and we know down here we have phosphoric acid. We're going to figure out what's the molarity of it. Over here we have NaOH that we use, and it was 0.501 molar. And now how much NaOH did we add? We added 14.2 ml, and then it turned, and then it turned color. It changed color. So far so good. We reached the endpoint. All right. Now, the beginning is exactly the same as before. You know how to do this. You have the molarity of NaOH, and you know how much NaOH you added. So the first thing you will always do, figure out how much of NaOH you added to this beaker, right? So I go molarity is moles per liter, right? Molarity is moles per liter. The molarity of NaOH is 0.501. I don't know the moles. I added 0.0142 liters. You following me? Okay, so I'm trying to figure out how much of the NaOH I added. I have the molarity, I have the volume, I can figure out how many moles I added. So I'm going to solve for x. If I solve for x, I get 0.00711 moles of NaOH. I added 0.00711 moles of NaOH. Beautiful. Okay, I added 0.00711 moles of NaOH and I changed color. How many moles of phosphoric acid I had? You're probably tempted to get the same number, and that would have been okay. That would have been the right answer if phosphoric acid was a monoprotic acid, but it's not. So this is the first example that we have doing an acid that is not monoprotic acid. So let's go over how to deal with an acid that is not monoprotic acid. So again, if this was HCl, this number would be the same number moles of HCl, or with HNO3. This number will be the same because for every NaOH, you would neutralize one acid. Now, what's going on here? So, and we've done this before. So I want to reiterate what I just said. I said, if this was HNO3, we would be done. This would be the same number of the acid. Because NaOH has one OH. Do you agree? And nitric acid has one H. So this is 1-to-1 ratio. For every HNO3, you would need one NaOH. One NaOH for one nitric acid. Okay? The last problem we did, we said ascorbic acid was a monoprotic acid. It was HA. So for every ascorbic acid, you would need one NaOH. Now, what has changed here? This is what has changed here. We still have NaOH as our base, but our acid is phosphoric acid. So NaOH, each NaOH has one OH. Stay with me. To neutralize one phosphoric acid, how many NaOH are you going to need? You're going to need 3 NaOH because one phosphoric acid, one acid has 3 H+. One acid, one phosphoric acid, 1 moles of phosphoric acid has 3 H+. So for one acid, I would need 3 NaOH. You guys follow that? Okay, I know you follow that, but I want to repeat it anyway. So if this was a monoprotic, in all the examples we've done, acetic acid, nitric acid, ascorbic acid, those were all monoprotic. The acid has only one hydrogen. That was easy because when you figure out the moles of NaOH, that would be the same as moles of the acid because it's a 1-to-1 ratio. For one nitric acid, I would need 1 NaOH. Now, this is the first time that we have an acid that is not monoprotic acid. So this acid is triprotic. So one acid has 3 hydrogen. One acid has 3 hydrogen. So to neutralize one acid, how many NaOH do you need? You need 3 NaOH to neutralize one acid because one acid has 3 H+. We're good so far? Okay. So what does this mean? This means that I have to do a mole ratio. So I have 0.00711 moles of NaOH. But I don't want moles of NaOH. It's going to go way down here. What I want is a moles of phosphoric acid. And we said for one phosphoric acid, because one phosphoric acid has 3 hydrogen, for one phosphoric acid, I need 3 NaOH. For one phosphoric acid, I need 3 NaOH, alright? Okay, so when I do that, what I end up getting is 0.00237 moles of phosphoric acid, okay? Because it was not a monoprotic acid. Now, are we done? We're not done. The question asks you for molarity. Remember, molarity is moles per liter, right? Molarity is moles per liter. The question asks you for molarity. So the moles of the acid is 0.00237. How much of this phosphoric acid did you have? You had 10 ml. That's what we were trying to figure out. You had 10 ml of the phosphoric acid and you were trying to figure out the molarity of that. Okay, so again, you have to have liters. So you divide that by 1,000, you get 0.0100 liter. Molarity is moles per liter, molarity is moles per liter, you know that. What you get is 0.237 molar of phosphoric acid. Okay, so now we've done all sorts of titration problem. This is a titration problem where the acid is not monoprotic, it's triprotic, so you have to care about the ratio. Now, if you understand this, this is the easiest way or faster way to do this. Understanding that for 1 moles of this H3PO4, you need 3 moles of NaOH because one acid has 3 hydrogen, so you need 3 NaOH to neutralize it out. Now, sometimes it's hard to see that or you're not sure about, or sometimes the ratio doesn't work as well. Another way to come up with this ratio is to do a balanced equation. This is faster if you understand this. This is the quickest way to do this, but I do want to show you that part also to kind of, you've seen both ways. That if you're having a hard time seeing that ratio, you can also do a double replacement reaction to figure out that ratio. You ready to do double replacement reaction? So what we have here, we have NaOH plus phosphoric acid, right? Double replacement reaction. This is an acid-base reaction. In is with inis, out is with outis. So I have NaPO4. Na has a +1 charge. PO4 has a -3 charge. So it will be Na3PO4 plus H plus OH is, you know it, water. And always remember, every time you have an acid-base reaction, water is a product. Okay, now we have to balance it. If I balance it, I have 3N over here. I put a 3N over there. Okay, so that's good. 1, 1, and then what do I have? Then I have, so sodium is balanced, phosphorus is balanced, that's great. How about the oxygen? How about the hydrogen? I have 3 hydrogen here, 3 hydrogen here. That would be 6. So what I would have to do, add a 3 over here. Okay. Now, by doing this, here is a mole ratio. 1 phosphoric acid for 3 NaOH. 1 phosphoric acid, 3 NaOH. And that's what I had over here. And that's what I had over here. Again, you can do it without doing the balance equation, or you can do it in your head and then check it for the balance equation, but that's the way to do it. Yeah? Okay, nice job. I feel pretty good about this. We've done a lot of titration problem. I will see you guys next time.